Hello everybody, it's Mr. Spinelli. Going to do a quick little review of some limits. So this first one's asking us to use this graph to the right, and we've got to compute the limit as we go to -3 from the right. Now that appears to be -4. And then we have to compute the limit as we go to 5 from the right, which appears to be -2. Now that's for this limit, which needs to be multiplied by 3. So then I've got -4 plus 3 times -2, which ends up being -10. The next one, I've got the limit as x goes to 1. So as x goes to 1 from the left, I get -2. From the right, I get -2. So this portion right here would be -2. And then I have cosine of pi times 1, which would be cosine of pi is -1. So I've got 1/2 times -2 minus 1, which would be -2. Number 3, I'm approaching 4 from the left. Well, it doesn't really matter which side I come from, because either way, when I approach 4, I get a value of 3. And then as x goes to -infinity, this thing is going down, so this will go to -infinity. And then the limit as I approach -3 is where I actually have to consider the left and right-sided limits. From the left, I get 2. From the right, from our answer to number 1, part of it, we get -4. So that one does not exist because the left and right-sided limits do not equal one another. Now in the next series of questions, I need to compute the limit algebraically or analytically. So first thing I'm always going to do is just plug in the value. So in the first one, I plug in 0, and I get 0 over 0, which means I've got to do some factoring. So I could factor out an x on top. I'm actually going to write this one a different way, just to emphasize this method. I could rewrite it as x cubed over x minus 2x squared over x plus 3x over x. So each term in the numerator is placed over x. And then that simplifies to the limit as x goes to 0 of x squared minus 2x plus 3, which is exactly what would be left in my numerator if I factored out an x. So it's the same end result. And now I plug in 0, and I get 0 squared minus 2 times 0 plus 3. So ultimately I just get 3 as my answer. Next one involves tangent and secant. So what I'm going to do is rewrite it using sines and cosines. So I've got 3 sine of x over cosine of x over x times 1 over cosine of x. I will leave it to you to determine that these cosines can actually cancel. They're both in the numerator of the bigger denominator and numerator. Sorry, they're in the denominator of the respective numerator and denominator. So then I get the limit as x goes to 0 of 3 sine of x over x. This portion of the limit goes to 1 as x goes to 0, so I just get 3 times 1, which is 3. The next one is looking at a limit from the right of 3. So I'm not going to plug 3 in. I'm going to first factor this. Factored form will help me analyze what this is going to go to, because if I plug 3 in, I get 0 on the bottom. So I know this is either going to be a positive or negative infinity, and factoring will help me determine that. So top factors like that. Bottom is x minus 3, x plus 2. So my x plus 2's cancel, and I'm left with the limit as x goes to 3 from the right of x minus 2 over x minus 3. Now, the bottom again still gives me 0, which means I know I've got an infinity. If I plug in a number like 3.001, x minus 2 is going to be positive, and x minus 3 is also going to be positive. So this will be positive infinity. If you want, you can make like a a little sign chart. And so I consider what is the the positive or negative nature of these two functions to the left and right. So from the right of 3, both of these are positive. So positive divided by a positive is what gave us positive infinity. If I were considering the limit from the left, this would still be positive and this would be negative, so we would have got negative infinity. And you have to consider that we're very, very close to 3, because obviously x minus 2 is eventually going to be negative to the left of 3. But we're talking about in very, very close proximity to x equals 3. The next one is natural log. This one's actually easier to think of graphically. We haven't touched on this yet analytically, so I'm just going to show it graphically for the sake. It's going to shift right 2, so our vertical asymptote will be at x equals 2, because you can't take the natural log of 0. And then the negative out front just flips it so that it looks more like this. So as we approach 2 from the left, we get negative infinity. So I'm looking at that from more of a graphical standpoint. The next one, be careful. Now x is going to infinity. So a real quick look. The highest power on the bottom is x cubed, and on top it's also x cubed. So you should be able to look at this and go immediately that this is going to be negative 1/3. But what I'm going to do is I'm going to factor out that highest degree of x from both the denominator and the numerator. So I'm going to factor out the x cubed that I highlighted in pink, because that was the highest power of x in the denominator. So I factor that out from both the numerator and the denominator, and I didn't even factor on top. So I get 1 minus 2 over x plus 3 over x squared. And then I get 1 over x minus 3. So ultimately I have the limit as x goes to infinity of everything that's in parentheses. So then everything with an x or x squared in the denominator is going to go to 0 when I evaluate the limit as x goes to infinity. So I get 1 minus 0 plus 0 over 0 minus 3. So ultimately I get 1 over negative 3, which is negative 1/3. The next one, I'm doing the limit as x goes to infinity. That's just going to be 5 plus 0, because any term with an x in the denominator of any power, positive of course, will go to 0. Next series of questions, I've got to use this piecewise function g of x and this graph of a piecewise function f of x. So it says, is g of x continuous at x equals negative 2? So what I want to compute is the limit and the function's value. But to do the limit, since it's a piecewise function, I have to consider a left-sided limit and a right-sided limit. All right, so from the left, that would be where x is less than negative 2. Okay, so then I'm going to be plugging in negative 2 into that piece. So negative 2 plus 3, and I get 3. Now from the right, that's where x is greater than negative 2, so I'm going to use this component. And then that'll be cosine of negative 2 pi over 2, which is cosine of negative pi, which is negative 1. So immediately, since the limit doesn't exist, I know it's not continuous. But just to emphasize, since this was or equal to negative 2, this green piece is the same as g of negative 2. So my right-sided limit and my function's value are the same, but the limit does not exist. So not continuous, because limit as x goes to negative 2 of g of x does not exist, because the left-sided limit does not equal the right-sided limit. So I've said that, you would need to write that. Next question is, for what values of a is g of x continuous at x equals 2? Okay, so now I'm looking at this piece and this piece. I want it to be continuous at x equals 2, which means the limit from the left, that's going to be this one, and the limit from the right need to be equal to each other. So I would write limit as x goes to 2 from the left of g of x is equal to, replace x with 2 in that middle piece, so I've got cosine of 2 pi over 2. Cosine of pi is -1. And then I've got the limit as x goes to 2 from the right. That's going to be the bottom piece circled. So 2 squared, so I've got a times 2 squared plus 2 times 2 equals 4a plus 4. And since I want it to be continuous, by the way, this is also the same as g of 2 because of the or equal to component. So I want all of these things to be equal, so I have to set -1 equal to 4a plus 4 and simply solve for a. So I've got -1 equals 4a plus 4. So I've got a, I'm going to subtract the 4 to get -5, and then divide by 4 and get my answer. Next question asks, for what values of b is the function discontinuous, and the function being f of x, so where that graph is. So it's discontinuous at x equals 0, 1, and 4. And it's discontinuous for different reasons at each of these. At x equals 0, the function isn't defined, and you could argue that the limit does not exist because it's negative infinity. There is no right-sided limit, and we don't talk about one-sided continuity, but the function isn't even defined at x equals 0. A similar thing applies at x equals 1. Since the function is not even defined there, it can't be continuous. If it were filled in, it would technically be continuous in a one-sided nature, but you don't have to worry about that for an AP test. And then at x equals 4, the limit is equal to 1, but then the function's value is -3. So the limit does not equal the function's value. So those are discontinuous for slightly different reasons. And then it says, at which of these values does the limit exist? Explain your reasoning. Well, that's precisely because the limit as x approaches 4 of f of x was equal to 1. But again, f of 4 was equal to -3. So because those weren't equal, it was not continuous, but the limit does still exist. Now this last problem is asking me to find the limit as x goes to 2 from the left of g of x plus 2f of x. So I'm going to 2 from the left. That was a positive 2, correct? 2 from the left. I did that once in this boxed component, and I got -1. So this part was -1, and then I have to add twice the value for f of x. Now f of x, as I approach 2 from the left, well, it doesn't really care which side I approach it from, because the function is even continuous there. I get a y value of 1. So then I've just got -1 plus 2 is 1. Now it's asking which of the following limits does not exist. Give reasons. So the limit as x goes to 1 of f of x, that doesn't exist because there's no left-sided limit. Okay, the right-sided limit is equal to -2, but the two-sided limit, which is what this is asking, does not exist. So this one does not exist because the limit as x goes to 1 from the left of f of x does not exist. So it can't possibly equal the limit from the right. As x goes to 4, we have discussed that already. The limit does exist. It is equal to 1. You can see that from the answer to number 14. So obviously it does exist. Then the limit as x goes to 0 from the left of f of x. So that's this part here that's going down to -infinity. So you could argue the limit does not exist, or you could be more specific and say it's -infinity, which is not a finite number, therefore it does not exist, but there's some information. Find the values of k and m so that the function below is continuous everywhere. So what I need to do is consider what happens at x equals -2. So I'm going to compute a left and a right-sided limit. So limit as x goes to -2 of f of x. So from the left, I'm looking at this one. From the right, I'm looking at this one. So plugging -2 in on the left, got -2 squared minus k times -2 plus 3. A little simplifying, I get 4 plus 3 is 7, and I get 7 plus 2k. Now when I do it from the right, limit as x goes to -2 from the right, I forgot my minus sign up there, using that middle piece. So I've got 2 times -2 minus 3, so I got -4 minus 3 is -7. For it to be continuous, these limits have to be the same, and they have to be the same as the value of my function, which is conveniently the same as the right-sided limit. So I need to set the -7 equal to the 7 plus 2k. Now I'm going to move on to the next value where my piecewise function splits up, and that's x equals 3. This will now be my left-sided limit, and this will be my right-sided limit. So we'll switch to pink for that. So limit as x goes to 3 from the left of f of x, and the limit as x goes to 3 from the right. These are going to need to be the same. The limit from the left is the same as the function's value at 3 because of the or equal to component. So I've got 2 times 3 minus 3 for the left-sided limit and the function's value. 6 minus 3 is 3. And then finally from the right, well, it's just a constant. It's 3 minus 2m, whatever that is. So again, these need to equal each other now. So ultimately, I've got 7 plus 2k equals -7. 3 minus 2m equals 3. So sometimes I end up with a system of equations, but these two equations are independent of one another. The k and m do not appear in both. So with the first one, I get k equals, I subtract 7, I get -14, divide that by 2. On a good day, that's -7. And then the second one, I'm going to subtract 3 and get 0, divide by -2, and I'll still get 0. So those are my values of k and m. Next question is asking for a limit as x goes to 0. This one's nice. I'm just going to plug 0 right in as I always do. And this particular one is nice. You get -3. Some of you are going to see right away that that's just living right there. Because x being 0, those 4x and 7x contribute nothing. Next one says limit as x goes to 1/3. I know I'm going to get 0 on the bottom. And on top, I noticed that 1/3 squared would be 1/9. So 1/9 times 9 is 1. 1 minus 1 is 0. So I get 0 over 0. That means I need to do some factoring. Let's go to green. So the top is actually a difference of squares. It is 3x minus 1 times 3x plus 1. And conveniently, the 3x minus 1s will cancel. And then I'm ultimately just going to plug 1/3 in for x. So I've got 3 times 1/3 plus 1. So 3 times 1/3 is 1. 1 plus 1 is 2. The next one, I've got a classic difference of cubes over difference of squares, both of which have values of 0 when x approaches 2. So I've got to do the limit as x goes to 2. And I've got to remember my rule. So this is a and b are x and 2 respectively. And some of you may remember SOAP, same, opposite, always positive. Or you can do synthetic division. So I know that 2 is going to divide that. I'll do a little synthetic division on the side in a moment. Then the bottom is just x minus 2, x plus 2. My x minus 2's cancel. I'm going to plug in 2 now because I'm evaluating the limit with direct substitution. So I've got 2 squared, emphasizing with those parentheses because when these are negative values, that's when you start to make mistakes. So 2 squared plus 2 times 2 plus 4, those are all just a bunch of 4's being added together. So I'm going to write that as 3 times 4 over 4, which gives me a value of 3. So just a quick reminder, x cubed minus 8, so 1x cubed plus 0x squared plus 0x plus, minus 8. I'm synthetically dividing that by 2 because I know x minus 2 goes into this. So then I got 2, 2, 4, 4, 8. And that's where you can see that I got 1x squared plus 2x plus 4. Okay, so if you don't remember your SOAP, remember you can always do synthetic division. The function g of x is not continuous at x equals 2 because, well, it looks like I need to consider my limits. Limit from the left, this is a little tricky, it's kind of backwards. My limit from the left is going to be down here, and that's going to be equal to 3 times 2 minus 7, which is negative 1. My limit from the right is going to be up here. That's going to be equal to 2 minus 3, which is negative 1. So since those are the same, I know my limit exists, but the function's value is negative 5. So the limit was negative 1, the function's value is negative 5. So this should be my reason. G of 2 is defined, right? It's defined here because x equals 2. The limit does not exist. That's not true. We found it to be negative 1. So it should only be option C. Option E. Have fun with that logically. All right, the last one here on this page. I'm going to notice that the highest power on top is cubed. On bottom, it's the same. I'm doing a limit as x goes to infinity. I know I'm going to get 7 halves, but let's do that algebraically. So I've got the limit as x goes to infinity. Since x cubed is the highest power of x in the denominator, I'm going to factor out x cubed from both top and bottom. So I've got minus 3 over x plus 7 plus 2 over x cubed. And then in parentheses on the bottom, I've got 2 minus 3 over x plus 5 over x cubed. Now these cancel. I evaluate my limit as I go to infinity. I get negative 0 plus 7 plus 0 over 2 minus 0 plus 0. Anything with an x in the denominator is going to go to 0. So I end up with 7 over 2, which some of us would have seen just by looking at those coefficients of positive 7 over 2. All right, now I got the limit as x goes to negative 2. Usually the case here, I'm going to have to multiply by the conjugate. If I plug in negative 2, I get 0 over 0. So I'm going to multiply top and bottom by the square root of 2x plus 5 plus 1. Same thing on bottom. I've just effectively multiplied by 1. It's just a little bit of a fancy one. Got limit as x goes to negative 2. Multiply out the top, I've got 2x plus 5 and then minus 1, so that's going to become 2x plus 4. And then on the bottom, I've still got the same thing. I'm not going to multiply that out. It'll just get messier. So then what you got to notice is the top is really 2 times x plus 2. So then the x plus 2's cancel, and you're left with just a 2 on top. So you've got the limit as x goes to negative 2 of 2 over the square root of 2x plus 5 plus 1. Now you can plug negative 2 in, and on bottom you get the square root of 1 plus 1, which is 2. So we get 2 over square root of 1 plus 1, which is 2 over 2 is 1. Next one, we've got to compute what's called the difference quotient. So I've got to replace x with x plus h for the first part. And then I've got to subtract the original function. So minus 3x squared minus 5x. But notice I put parentheses, so I'm sure to distribute. And then, of course, I'm actually evaluating the limit of that. So I should continue to write the limit as h goes to 0. So then I've got the limit as h goes to 0. I've got to expand everything on top. So I end up with 3x squared plus 6xh plus 3h squared minus 5x minus 5h minus 3x squared plus 5x, because I was careful to distribute that negative correctly at the end. And then 3x squared minus 3x squared, negative 5x plus 5x, those cancel. I'm actually going to factor out an h on top. So this h will be gone, this will become just h, and that h will be gone, and it'll cancel with the h in the denominator. So I invite you to make sure you show that step. So I end up with 6x plus 3h, because that h was squared. But now I've got 6x plus 3 times 0 minus 5, so I end up with just 6x minus 5. Next one is a limit as x goes to negative infinity. So I notice effectively on top I have an x, and on bottom I have a square root of x squared, which is basically an x. So I know this is going to go to some number other than 0 or positive or negative infinity. And if you're clever, you should be able to see that this is probably going to go to positive 5. But let's do some magic. By magic, I mean math. So on bottom, we've got a square root of x squared that we're going to factor out. So just a side note, that bottom is going to be x squared times 1 plus 2 over x squared. When I have a square root of x squared, it's really the absolute value of x. And I'm left with what I've got in parentheses over there, still in the square root. And since I factored out an x on bottom, it's an absolute value, of course, but I'm going to factor out an x on top, so I've got 2 over x minus 5. Now, because this is the limit as x goes to negative infinity, and because the absolute value of x is negative x when x is less than 0, I can rewrite this as x times the same stuff on top in the numerator, but the absolute value of x becomes negative x, because the absolute value of x is really a piecewise function, and it's negative x whenever x values are negative. So ultimately I'm left with a negative 1 out front. That cancels into just a negative 1. So then I've got negative 1 times anything with an x in the denominator goes to 0. So I've got 0 minus 5, and then I've got the square root of 1 plus 0. So I've got 1 in the denominator, I've got a negative 5 in the numerator. Negative 5 times negative 1 gives me positive 5. Next one, it says the function has a vertical asymptote at x equals negative 5 because, so let's take a look at this. I bet if I plug negative 5 in I get 0, but I'm going to rewrite this. So I got to do some factoring here, which means my brain has to turn on. So I think we're going to have a plus 1, or actually a minus 1, and then a plus 3. So that gives me minus 2x and plus 3x. That gives me positive x in the middle. That's good. On bottom, I think I can handle that one. That's going to be x plus 5 and x minus 1. So I have a removable discontinuity, or more layman's terms, a hole at x equals 1, because I was able to cross that out. But now if I consider the limit as x goes to negative 5 from the left, and then again from the right. So I'm basically plugging in negative 5.001 from the left. So that bottom term is going to be negative. But then negative 5 whatever, doesn't really matter, times 2 is negative 10 plus the 3 is also negative. So I get negative over a negative for this one to be positive infinity. So limit from the left is positive infinity. That is true. Limit negative 5 from the right, so negative 4.999. Now the denominator is positive, but that numerator is still negative, so I get negative infinity. So limit from the right, did I do that right? Negative 4.999 still makes that top negative, but the bottom would be positive. So that's the only reason that I can find, because the limit from the right should be negative infinity if we want to change option A a little bit. And because those are different, the limit as x goes to negative 5, like a two-sided limit, doesn't exist, but that's not really relevant here. We just need to show that the one-sided limits go to plus or minus infinity. We got a true statement. Which of the following are true, is or are? Limit from the left I'm going to look at. That's up here. Replacing x with 3, I get 9 minus 5 is 4. Limit from the right also the function's value. So h of 3 is going to be the same as the limit from the right. 3 squared is 9. 9 minus 6 on a good day is 3. So limit does not exist. Limit from the left does equal 4. And it's most certainly not continuous because the limit does not equal the function's value. So 1 is the only thing that is true. Now we've got an IVT question. Remember, the first thing you want to check is continuity. That can save you a lot of time. G of x is discontinuous at x equals 1 because that would give us 0 in the denominator. It's also a vertical asymptote, which is in the interval. So we can't do anything with this. Which is in -2 to 4, the interval that we were concerned with. So IVT does not apply. And then we've got the next one is asking about the same function, but now x equals 1 is no longer in this interval. So we've got that it's continuous. And I should write g of x is continuous on the interval 2 to 4. And now I need to compute my endpoint values. So I'm going to check g of 2. I'm going to check g of 4. So if I plug 2 in, I've got 2 plus 2 over 2 minus 1. And a good day is 4. And then I've got 4 plus 2 over 4 minus 1. 6 over 3 is 2. So then I ask myself, is 3 in between 2 and 4? Yes. So because g of x is continuous, so I would write that, because g of x is continuous, and g of 4 is less than 3 is less than g of 2, which is me saying because y equals 3 is an intermediate value, it's in between my endpoint values of 2 and 4, right? These were 2 and 4, then IVT applies. So because of all that I would have written is because tells me that IVT applies. So now I need to find a value such that this function, when I plug in c, so c plus 2 over c minus 1, needs to equal 3. So that I've got c plus 2 equals 3c minus 1. On a good day, that gives me c equals 3 halves, which I should verify. Did I do math wrong? 3 over 2, c plus 2, c minus 1. Come on, Mr. Spinelli, you got to distribute better than that. So 3c minus 3. So then I've got 2c equals 5. So I've got c equals 5 over 2, which is about exactly 2.5, which is in the interval between 2 and 4. So you got to make sure you check that that's actually in your interval. Hopefully this helps. Thank you for watching.